which is on differential aeration. This is on page 32. And as we already have discussed, we know that oxidation occurs at the anode. And that this is in the lower oxygen environment. And so we have a lot of examples in our applications of iron, where we use iron and steel, where we can't see all of it. And one of that might be in the case of a bolt or a nail that's gone into some timber or wood or something like that. So we've got, basically we only have the head exposed. And so what happens here, and this is, I might make it a screw so that it doesn't really matter. It doesn't matter. All of this area that is under the surface is low oxygen. So what does that mean? What's going to happen under there? Oxidation. So Fe to Fe2 plus. And so the nail head is in that higher oxygen and also exposed to water if it rains or if it's high humidity. And so we're going to have reduction occurring here. And the rust accumulates at that interface there between the anode and the cathode. Remembering again that we have our electrons moving. This time it can't move through the timber or the concrete. It's going to need to move through the nail or whatever it's made of. The electrons are going to be moving through the metal. And because this is all happening under the surface where we can't see it, it means that we can have lost structural integrity, because this is all rusting away, but the head looks fine. We can't tell by just looking at the top here just how corroded it is under the surface. And friends of mine had a swing in their backyard, and it was like they had some eyelets for the rope to hang off, and these were just like screwed into timber like that, and so the swing went off like this. And then guess what happened? Like this swing worked perfectly fine for about 10, 15 years, and then one day someone gets on to go for a swing, and these just pulled straight out because there wasn't enough metal left in them anymore. Okay, straight down. And so you could look at all of this part here and it all looked fine. Everything looked fine, but it wasn't. Okay, so anywhere where we've got the same object exposed to different levels of oxygen, again we can determine where the anode and the cathode are going to be. Okay, so this is the one object. We've got two environments of differential aeration. You do need to remember this term because it could be a question, could just say, explain where is the differential, or why is this differential aeration, and so if you don't remember what the term means, it's going to be hard to answer. hydroxide. It also is good if you can use that in an explanation as to what's happening, because that means that you can use two words to explain something that might otherwise take you a sentence. Okay? Our reactions are still the same. If you look in your booklet, this is still producing the hydroxide ions at that site there. Okay, we haven't swapped over. We have to make sure that we've got that half equation firmly planted in our minds.